Hello and welcome. My name is Mukelabai. I'll be talking about a technique for semi-automatically propagating test cases between forked projects. This is joint work with Thorsten Berger and Paulo Borba. Developers often fork projects to adapt them to different requirements. Let's assume that you are a developer working on a basic calculator with 4 math operations, and some time later, another developer is requested to build a scientific calculator. So instead of building that calculator from scratch, this developer forks your project and then adapts it to build the scientific calculator. As part of quality assurance, you then decide to add a test case that exercises the divide method of your basic calculator. Now, the other developer of the scientific calculator is busy implementing the new functionalities and has got no time to test his project because, as it turns out, testing can take up to 50% of the development cost. But we realize here that this test case could be propagated to the scientific calculator and could be reused to save this developer effort as well as improve the quality of his scientific calculator. So what if we could have a technique for recommending and propagating test cases? Now, Github has a similar feature that recommends fixes for vulnerable dependencies in a project. When you go to a GitHub page of a project, under the Security tab, you might find a link that says Dependable Alerts. This is where it provides these recommendations for fixes to vulnerable dependencies. So similarly, we propose a technique that would allow developers of forked projects to share test cases, thereby reducing effort and improving the quality of their projects. For example, here we have a test case for the basic calculator class. We would want to assess whether this test case can be applied to the target project, which is a scientific calculator. And then from there, we would recommend this to the maintainer of that target project. And if accepted, we want to propagate that test case and adapt it to the target project. But what is the potential for a technique such as this one? To answer that question, we analyzed 12 ecosystems from the Android ecosystem. And by ecosystem, we mean 12 groups of forked projects. So there are 12 mainline and 31 forks. In total, there were 43 projects. And these projects had 6,569 test cases in total. What we wanted to understand was for each ecosystem, for each group of forked projects, what is the proportion of shared test cases? And then for the test cases that are not shared, what proportion of them has matching units under test in the projects where they're missing from? So we found that for half of the ecosystems, the projects in those ecosystems shared more than 75% of their test cases. And this is good news. Then we also looked at those projects that had missing test cases. We found that for 25% of the ecosystems, the missing test cases were more than 60% of the missing test cases were missing in 1 out of 4 projects. More than 75% were missing in half of the project, and more than 87% were missing in 3 out of 4 projects. So this shows some potential. We then wanted to look at these missing test cases and see whether they had any matching units under test in the project where they're missing from. So we found that for 75% of the ecosystems, at least one test case that was missing had a matching unit under test in other project. And then we found that for the top 25% of these ecosystems, the majority of the missing test cases had matching units under test, and these were between 60 and 100%. So this is good news, and it shows potential for our technique. Now, several works have been conducted to reuse test cases across different projects. For example, there's a technique that proposes the use of, a technique that reuses test cases for fragments of clones or cloned fragments. There's also another technique that proposes test cases based on the features that are used in a project. And then there's also test case reuse that has been proposed for visual UI testing in web applications, in mobile apps, and so forth. However, our technique is different because we are looking at recommending and transplanting test cases in forked projects, and this has not been tackled before. So how does this technique exactly work? There are 5 main steps to it. The first one is that when a test case is added in the source project, we want to get the units under test for that test case, and then we want to identify projects that can benefit from the test case. Then third, we want to assess whether this test case can be applied to those projects or to the target project. And fourth, we want to recommend to the maintainers of that of those projects. And lastly, we want to transplant the test case in the target project. So when assessing applicability, there are three main parts to it. The first one is that we want to check whether the test case exists. Now, here we have a test case that checks the divide method. The fact that it is called divide may not mean that this unit under test or this method is not tested in the target project. So a test case could be modified in the source and in the target project, and we want to check whether it actually exists or not. And for this, we could use techniques such as AST differencing to check whether the test case exists or not. The second part to assessing applicability is to identify the variations in the unit under test. So the units under test here, meaning the divide method of the basic calculator class, could also have changed in different ways. And we want to check whether there are any variations, for example, in the methods that are, or in the variables that are used within the method, or the variables that are affected by the method. We also want to check if there are any variations in the dependencies. For instance, the scientific calculator might be using an updated version of a math library, whereas the basic calculator might be using something outdated, and that might make the test to fail. So we check for such variations. Once we have these sets of variables used and variables affected, we can then map them between the source and the target project. For example, we can see here that in the source project, we have the basic calculator class that can be mapped to the scientific calculator class. We also have the divide method of the basic calculator that can be mapped to the divide method of the scientific calculator. And one question here is, how much of this context of the test case do we need to analyze for us to be precise? And how fast can we perform this analysis? Once we have these sets of variables that have been mapped, the next step is to propagate the test case. And here we want to transplant the code of the test case and its related code. So in transplanting, of course, we would need, as you can see here, if we just move the test case as it is, we are bound to get some errors when building this project. So we would have to adapt the test case to the target project by looking at variations, for example, in the variable names, the method calls. If a method is used by the basic calculator test, which doesn't exist in the target, we need to copy it, for example. And here the question is, what kind of variations need manual adaptations, and how can this be applied in practice? So what we've used here is a simple example, but this could actually be very complex in practice. Therefore, our research challenges consist mainly in, first, analyzing test case applicability. How much of the behavior of units under test can we estimate in order to provide precise but fast enough recommendations? Secondly, we want to formalize an algorithm to adapt a test case. Under what modifications can we propagate a test case, and what kind of infrastructure is needed to support this technique? For example, if we have to build test cases to compare output of the test cases, are we going to make use of CI and so forth? And this requires an empirical investigation to calibrate different heuristics for assessing test case applicability, as well as adapting a test case to a target project. And these are our research challenges. So in summary, we presented a technique for propagating test cases from one project to another among its forked projects. We've shown that this technique has potential, and we've also presented our challenges, which mainly consist in empirically calibrating heuristics for assessing the applicability of a test case and adapting it to the target project. So thank you very much for your attention. I welcome your questions.
Okay, welcome again to this second paper of this session, Handling Ecosystems of Forked Projects. This second paper that you just watched the video is a semi-automated test case propagation in fork ecosystems. I have seen that there is no questions so far in the chat, but I have some questions for the authors. I will present them. Of course, we have Mukelabai here, and also Paulo Borba that will reply the questions. So welcome to this question and answer sessions. And my question, I think that your idea of taking advantage of the existence of test cases and the knowledge that the people, experienced people, put there when they design these test cases and the idea of reuse them is very good. So since this is a kind of vision paper, I would like to know what are your future steps to try to put forward your proposal?
What are the future what steps?
I think we have a little bit of connection problems. Mukelabai, can you hear me?
Yeah, I can hear you now. But you said what are the future what? Future steps or?
Steps that you are thinking on doing in order to put forward the proposal. To make them make it feasible.
So there are two main steps to our proposal. We conduct a study where we investigate how we can assess the applicability of test cases. And for that, like we said in the talk, that we need to understand characteristics that we can apply. Like when we say that this test case doesn't, is not present in the target project, and to check if we can actually apply it to the target project. So we need to investigate investigate that empirically. And then, of course, the next thing is to actually develop a tool that does this propagation and see if we, in the beginning, we can try something that is a standalone project, and then later on we can push it up, for example, where it's able to directly do these recommendations on GitHub, and then maybe using the GitHub API. So first we do the assessment of applicability, and then we do the tool that actually does the recommendations. So those are the two main things that we need to do. Yeah.
Thank you, Mukelabai. It was a little bit hard for me to follow the answer because I lost a bit the connection. I don't know if the audience also experienced the same. But anyway, there are several questions here. Probably we will not have time to repass all of them during these minutes. There is another questions here that is good talk. They congratulated. What kind of test cases are propagated and more often compared to others?
So in the study that we did, we mainly focused on unit tests. But it would be nicer to actually look at a broader view of tests, maybe integration or regression tests. But we're really focusing on unit tests in the initial study that we did. And those, of course, we found that there were a number that were shared across projects. But we still need more investigation to check really what kind of tests can we propagate, whether regression tests or.
Okay, thank you. There is another question. I'm not sure that we will have time to hear the answer here, but as I say, that there is always a discussion room after the paper presentation, so all the authors will be moved there. And so if we don't have time, I think it will be the case. All the questions that are here in the chat, as for instance, Leopoldo Teixeira and Timothy, that made some questions, they can continue the discussion in the discussion room. So thank you, everybody, for attending to the session. I think we are almost running out of time. We will have just some seconds. So, and probably it will be just better in the discussion room because some of the audience are putting here in the chat that they cannot hear as well.
Hi.